Have you ever felt like reality is not quite what it seems? That there are deeper, stranger rules at play just beneath the surface? Well, you might be right. Today, we're diving headfirst into the mind-bending world of the quantum paradox, where the very act of looking at something changes what it is. Let's start with a particle that shattered our understanding of everything. Imagine a single electron. Simple, right? But in the quantum realm, this tiny particle can exist in multiple places at once in a ghostly state of probability. It's not here or there, it's everywhere, until we look. The moment we try to measure it, to pinpoint its location, its cloud of possibilities collapses into a single, definite point. This is the observer effect, and it's our first clue that reality isn't a fixed, solid thing. It's a dance between potential and actuality, and our observation is a key part of the choreography. What happens when the universe itself changes just because we looked at it? It's a question that has baffled scientists for a century. To really see this in action, we need to talk about the most famous, most baffling experiment in all of physics, the double-slit experiment. Picture a barrier with two narrow slits in it. If you shoot tiny pellets, like sand grains, at it, you'd expect to see two lines of sand on the wall behind, right where they pass through the slits. Simple enough. Now, let's do it with electrons, the building blocks of matter. If we fire them one by one, you'd expect the same thing, two neat lines. But that's not what happens. Instead, we get a pattern of many lines, an interference pattern, as if each single electron acted like a wave, passed through both slits at the same time, and interfered with itself. It's like it knew both paths were open. But here's where it gets truly bizarre. If we place a detector at the slits to see which one the electron goes through, the pattern changes. The wave-like behavior vanishes, and we get just two lines, exactly like the sand. It's as if the electrons know they're being watched and decide to act like normal, well-behaved particles. The simple act of observing their path forces them to choose a reality. This isn't an illusion, it's proven, repeatable evidence that reality behaves differently when we look at it. The universe, it seems, is shy. This strange connection between observation and reality has led some brilliant minds to a radical idea: quantum consciousness. What if our minds, our very awareness, aren't just byproducts of chemical reactions in the brain? What if consciousness itself is a quantum phenomenon? The idea is that the brain might operate like a quantum computer, harnessing these strange effects to produce thought, self-awareness, and our subjective experience of the world. Could the collapse of possibilities we see in experiments be linked to the collapse of possibilities in our own minds when we make a decision? It's a wild thought, but it connects the biggest mystery of physics, the nature of reality, with the biggest mystery of biology, the nature of consciousness. Is your mind a quantum event constantly shaping the world around you? Let's push this even further, across the vastness of space. Meet quantum entanglement, what Einstein famously called spooky action at a distance. Imagine you have two particles that are linked, or entangled. They are now part of a single system, no matter how far apart they are. If you measure a property of one particle, like its spin, you instantly know the spin of the other, even if it's on the other side of the galaxy. It's not that the information traveled faster than light. It's that they are not separate things. Their fates are intertwined. A change in one is instantly reflected in the other. It's as if they are communicating but without any signal passing between them. How can two particles react instantly across galaxies? This defies our classical intuition about space and time, suggesting a deeper level of connection in the cosmos that we are only just beginning to understand. And if that's not weird enough for you, how about particles that seem to travel through time? In some quantum experiments, scientists have observed phenomena that can be interpreted as particles moving backward in time. Think of it like this: an event happening in the future seems to influence a particle's behavior in the present. This isn't a time machine in the science fiction sense, but it does challenge our linear, one-way perception of time's arrow. Some theories, like the Wheeler-Feynman absorber theory, propose that particles send out waves both forward and backward in time. It's a mind-bending concept that suggests the past, present, and future, might be more interconnected than we ever imagined. The time loop particle might just be a whisper from the future, telling us that our understanding of time is fundamentally flawed. With all these digital-like rules, particles being in one state or another, information being fundamental, it's no surprise some have wondered if it's all just code. This leads us to the simulation hypothesis. The idea is that the quantum world, with its discrete energy levels and probabilistic math, looks a lot like a computer simulation being rendered, when we're not looking at a part of the universe. Maybe the system saves processing power by not fully rendering it, leaving it as a wave of possibilities. Only when an observer, that's us, looks does the program need to render a definite outcome. The pixelated nature of reality at the smallest scales, the fundamental speed limit of light, the bizarre rules of quantum mechanics. Could this all be evidence that we are characters inside an incredibly advanced program? It turns what we call the laws of physics into the source code of our reality. So let's circle back to that central mystery, the observer effect. Does reality even exist if there's no one there to see it? This is not just a philosophical question anymore. It's a scientific one. The famous thought experiment, if a tree falls in a forest and no one is around to hear it, does it make a sound? Gets a quantum update. According to some interpretations, the tree exists only as a superposition of fallen and not fallen, until a conscious observer comes along and collapses it into one state or the other. Without an observer, there is no definite reality, only a sea of potential. It suggests that consciousness isn't a passive viewer of the universe, but an active participant in its creation. If consciousness can shape reality, what is consciousness? The traditional view is that it's all about neurons and chemicals. But a new frontier is exploring the quantum brain. This theory suggests that our thoughts might not be purely chemical, but quantum. Inside the microtubules of our brain cells, tiny protein structures, quantum processes could be happening, allowing for computations far more powerful than any classical computer. This could explain the mysteries of consciousness, intuition, and creativity. Your thoughts, your feelings, your very sense of self might be born from the same strange quantum fuzziness that governs the universe. You are not just in the universe is in you, at a quantum level. This leads us to a staggering conclusion. What if observation doesn't just reveal reality, but actually creates it? This is the core of interpretations like the Copenhagen interpretation. Before a measurement, there is no position, no spin, no reality. There's only the mathematical description of possibilities, the wave function. The act of measurement forces the universe to make a choice, to collapse the wave function and bring a single concrete reality into being. Our observation is the act of creation. We are not just discovering a pre-existing world, we are co-creating it moment by moment with every glance, every measurement, every interaction. Reality, in this view, is a participatory process. And this brings us to the final, ultimate question. If everything depends on an observer to become real, who or what observes us? If a physicist in a lab collapses a wave function, who observes the physicist? Does this require another observer and another and another in an infinite chain? Or is there a final observer, a universal consciousness that observes the entire cosmos, thereby collapsing it into the reality we experience? Some call this God, others call it the universe observing itself. It's the ultimate measurement, the one that holds everything together. From a single particle behaving strangely to the very fabric of existence, the quantum paradox forces us to confront the deepest questions of who we are and what this reality truly is. The answers are still out there, waiting in the ghostly realm of quantum possibility. Thanks for joining me on this journey into the quantum rabbit hole. If you enjoyed having your mind bent, be sure to hit that like button and subscribe to Into the Void for more explorations into the mysteries of our universe. What do you think is going on? Let me know in the comments below. Until next time, keep questioning everything.